Okay, so in this set, we will be talking about how to get the derivatives of trigonometric functions. Let's start by recalling the 6 trigonometric functions. What is the first? Sine, which is abbreviated by sin, cosine, cos, tangent, tan, and then cosecant, so CSC, and then secant is equal to SEC, and then cotangent, which is abbreviated as cot. Okay, and these are, well, the main 3 functions are sine, cosine, and tangent. The cosecant, secant, and cotangent are just the reciprocals of the 3. And that is sine to cosecant, cosine to secant, and then tangent to cotangent. Okay? Sige, a quick review of some identities because you might need them in the more advanced expressions. Tangent, so some identities. Tangent in terms of sine and cosine, so tangent theta is equal to sine theta over cosine theta. So that means cotangent theta is equal to cosine theta over sine theta, or in other words, it is the reciprocal of tangent. Cosecant theta, as we mentioned, is 1 over sine. Secant theta is 1 over cosine theta. And in some cases, we might need sine squared theta plus cosine squared theta is equal to 1. And I will just introduce the others when we need them in a problem. But the basic ones are these, the fundamental identities. Okay. Kinokopya niyo pa ba? So let's talk about the derivatives. Y equals sine x. The dy dx is equal to cosine x. Y equals cosine x. The derivative is negative sine x. Y equals tangent x. The derivative is secant squared x. Y equals cosecant x. Dy dx is equal to negative cosecant x cotangent x. Y equals secant. Dy over dx is secant x tangent x, and y equals cotangent x. Dy over dx is equal to negative cosecant squared x. Yan. So these are the derivatives that you need to remember. Okay, so we have to find a way how we can easily remember them. And this can be done with pairing the functions. In derivatives, as you can see, sine and cosine will always go together. Sine, cosine, cosine, sine. Tangent and secant will always go together. Cosecant and cotangent will always go together. So they pair up. And then secant. So as you can see, tangent, secant, secant, then there's a tangent. And finally, cotangent, from cosecant and cotangent, the other one must be cosecant squared, cosecant x. pattern did you notice? There are some positive and there are some negative derivatives. And when do these negative derivatives will come out? May nakita kayong pattern? Kasi kung minsan nami-mix up nyo, kailan ba siya nagiging negative? Kapag identify natin kapag cosine, kapag cosecant, kapag cotangent. Kung papagawan kayo ng rule, paano nyo hindi makakalimutan na negative siya dapat? Kapag narinig ko na.
Lahat ng C.
Lahat ng C. Diba? Di ba mas matandaan? Hindi naman C as positive, BNC is a positive, BNC is a positive. Lahat na nag-start ng C. Well, it's a, di ba parang sa tawag nila dyan, made up rule. Hindi man siya mathematical rule. But something that we use to remember it. Cosine is a negative, cosecant is a negative, and then cotangent is negative. So did you naman yung mix up yung sign? Okay. Aside from that, we have about, well, there are functions that will require a square. Kailan lang siya nangyayari? Tangent. At ang nagkakaroon ng square, yung secant. Okay? In the identity of tangent and secant, there's always two of the secants. There's always two of the cosecant. If I look for the derivative of the tangent, may dalawa akong secant. Secant times secant. If I look for the cosecant, meron na akong isa. Kailangan ko pa ng isa pa ako. And then cotangent. Derivative ng cotangent, kailangan may dalawang cosecant. So lagi silang dalawa. Then any group of identity or any derivative. Okay? So it's very important that you remember this because once we go to integration, magkahalo-halo yung rule nyo. Okay? It's just a reference, but we will talk about that later on. Okay? But in the test, you won't be asked, maybe in the short quiz, what is the derivative of sine? Then you answer cosine. We already naman kadali. Okay, so we will see more complex expressions or functions. Okay. So let's take, for example, so you might see something like this. Technically, it's a sine x, right? Sine x, but instead of just x, it's 2x plus 3. So together with the rules for the algebraic expressions, for trigonometric expression, we just extend it. This is like the chain rule for trigonometric functions. You have this nested of the parentheses. Okay, so in getting the derivative dy over dx, just get the derivative of sine. Forget about the 2x plus 3. It's cosine. It's cosine of 2x plus 3. But by the chain rule, we multiply it by the derivative of 2x plus 3. Okay, now be careful when you write the tail end of the derivative. If you write it as 2, this is mathematically incorrect. Why is it mathematically incorrect? Why is this wrong? The rule is, you get the derivative of 2x plus 3, you write 2. But why is this wrong? Okay, to correct that, there are two ways. First, take note that the 2 is multiplied to the cosine of 2x plus 3, and not just on 2x plus 3. Without the enclosure, it would mean that 2x plus 3 is multiplied to 2. So how do we safely write it? Yung other suggestion, you write it before the cosine. And that's for sure is 2 times the cosine, not on the 2x plus 3. Okay. Yan. Example number 2. And before we go for a break, y is equal to cosine of x to the, o lagyan natin, 4x cubed. Y is equal to 4x cubed. dy over dx, di ba, letter C na yung umpisa niya. So, negative, iano mo natin yung process, negative of sine 4x cubed, this will be multiplied to 12x squared, or negative 12x squared sine of 4x cubed. Yan. Okay? And ganoon lang, parang extension lang siya nung kanina. Okay? Abot ba tayo? Sige, ubusin ko muna yung example. Then, 15 minutes pa rin yung break nyo. Example 3, we have y is equal to tangent of, hirapan natin, tangent of cosine x. May tangent na, may cosine pa. Okay, but do not be confused with that cosine inside. dy dx is, diba, focus on the tangent. This is what you are trying to get. Derivative of tangent is secant squared. So just write secant squared, but inside is cosine x, and then the tail end of the derivative is, so times negative of sine x. Kailangan kukunin yung derivative ng cosine. And then just arrange negative sine x secant squared of cosine x. Yan. And then you can put a dot if you want in the middle. Ayaw. Yan. Okay, and then let's get something for secant. Example 4. So y is equal to secant of sabihin natin 5x squared minus 4. dy over dx is equal to, diba, dalawa. Secant of 5x squared minus 4, and then tangent of 5x squared minus 4. And then there's a tail to this derivative. So group times 10x. Yan yung tail end niya. Then again, arrange 10x. And then just copy 5x squared minus 4 times tangent of 5x squared minus 4. And then the rule will just be extended even if you have something like y is cotangent of 3x minus 1, or even y is equal to cosecant of, say, 5x squared minus 2x plus 1. Okay, I'll leave this two as an exercise. Okay, we'll have a 15-minute break. So we'll resume after 15 minutes. Okay?